remember I said a couple minutes ago, you could argue that just refly these rovers because we know they work and can do great science. Well, you could make the argument, what's NASA all about? NASA should not be all about just doing what it's already done, but doing new and exciting things. This is new and exciting, pushing technology. And I would argue one of the reasons, and you know, I'm in a room right now with about 50 people who are really interested in space. Am I correct on that? Is there anybody here who can name a single astronaut on the space station right now? Give me a name of an astronaut on the space. And you know, you're more likely to know the answer to this question than the general public, because you are people who are interested in space. If you're not interested in space, you're sure as heck not going to know the answer to that question. And the point I'm trying to make here is that people don't care about the space station because it's not doing anything new. We've had people in low Earth orbit going round and around the Earth since Yuri Gagarin in 1961. So you could make the counter argument, why we know this works, so therefore don't do it again, do something bigger and better, and this is the next step. So I think it's probably going to work, and if it does, it's going to be a phenomenal mission. We'll get even better pictures and better data, and this thing could last much longer than Spirit and Opportunity.
But there's no backup, right? No
backup. There's only one. Only one. So I guess what I'm going to do is I'll tell you right now how it's going to land. Okay?
So we're going to ask anyhow. So.
Okay, yeah, I figured you'd. So here's the problem. This thing, you can see, is pretty big and pretty heavy. You cannot use the same landing design that we've ever used before. Like, you can't use airbags. You can't use the same. You can't even use the method that worked with Viking, where you have like parachutes and retro rockets to slow its descent, because this thing is much bigger and much heavier than anything we've landed on Mars. Quick aside, you hear all this stuff about the Martian ghoul that gobbles up spacecraft. Well, that's mainly Soviet spacecraft, where they've had an unsuccessful Mars program. NASA's attempted 7 times to land spacecraft on the surface of Mars. 6 of the 7 times they've been successful. That's like a batting average over 800. I think that's pretty good. Okay, so NASA has a good, and you would expect out of 7 missions, you'd expect 1 failure. That was Mars Polar Lander back in 2001. You know, so NASA has a pretty good track record of landing things on Mars. So the way this is going to land, it's going to come into the atmosphere and it's going to have parachutes to slow it down, and then it's going to get to a point where it's slowed down enough. The landing craft, the rover is going to be inside this big landing craft, is going to start firing thrusters in all directions to get it to a point where it's hovering over the surface like a helicopter. Okay? And then the rover is going to drop down to the surface on a tether, where this thing's going to be hovering a few dozen feet above the surface, and the rover is going to slowly drop and make a very, very soft landing on the surface on a cable.
And then you cut the umbilical and it flies away?
Cut the cord and it drives away. Okay. Now that sounds like an incredible technical challenge, and it is. But the key point here, if you want to build something this big, heavy, and ambitious, we've got to try out a new technology. But this is a very, very high-risk mission.
How much does it weigh?
I don't remember off the top of my head. I could get that for you.
Okay.
Or the website will have that. But if it doesn't work, there will be congressional investigations. But if it does work, it's going to be another enormous triumph.
Congress will send people to Mars to make it fun.
Yeah, that's right. I can think of some congressmen I'd like to send to Mars on a one-way trip, too. On a one-way trip. But you know, my guess is, you know, they're going to test it and test it and test it. It probably will work, and if it does work, it's going to be very exciting.
It has to be completely automatic because it's 45 minutes away.
Yeah. This is all done automatically. You can't do this from Earth. But if it works, we now have a way to get heavier payloads onto the surface of Mars. And if we ever want to send people there, I mean, a human craft to land on Mars is going to be a lot bigger and heavier than this to get people onto the surface. So if you want to be ambitious, in my view, is that NASA should always be pushing the limit and trying new things. That's one of the big discoveries in NASA's history, and its glorious moments have come when it's pushed the envelope. So I'm actually excited about this mission, but I'm going to be very nervous the day of its landing. It's going to be a white-knuckle day for the scientists involved in the mission. So I just want to conclude by just mentioning that, and this is good timing, that our July issue is on the newsstands right now if you're not a subscriber. Now our newsstand copies also come with a DVD. It's not a DVD you can put in a DVD player, it's a data DVD with hundreds of pictures. In fact, most of the images I've shown you tonight are on this DVD, as well as some movies, so there's some really cool stuff. So you can either pick this up on the newsstand, or if you're a subscriber, you can either get it from our website, or you can just pick up a copy on the newsstand. So I want to thank you all very much.
Maybe we can have just a couple of questions, 3 questions, and then we'll break.
Yep.
When you're navigating those devices on the surface, it's a 45-minute time delay. So you
Correct.
Tell it to go, and how far do you? How long are each of the increments?
Okay. The question is, how long are the increments? Because of course Mars is many light minutes away, and
45.
the answer is it depends. It depends on how difficult the drive is.
Okay.
At the times when the rovers are in like a lot of rocks and boulders around, these are very short drives, maybe a few feet in a day. But on some of these longer drives, especially in Meridiani with Opportunity, there was one day I think that I showed, it was like hundreds of meters, where if it's like they can see straight ahead and there's nothing in the way that they're worried about, they can program it to go a very significant distance in one day. It depends on where it's located and how difficult the environment is. Yes?
The missions have gone way beyond their projected time spans. What has that extended life of the missions done to the careers of the scientists involved?
It's been great for the scientific, because it's given them more to do. So for example, the original thinking is we've got like maybe a few months, and you know, it was sold to Congress as a 90-day mission. They did expect it would go beyond 90 days. They thought it might go up to maybe 120, like half an Earth year was sort of like a realistic expectation. The idea was they get lots of data, and then they can spend like many years analyzing that data. That, you know, that data would be enough to take them into many years into the future to do the analysis. Well, now they have for each rover over 5 years of data. So this data set from both rovers is going to keep scientists occupied for decades into the future. So it means that if you're a Mars researcher, you've got a lot of great data. I mean, there's probably going to be discoveries made after the rovers died from looking at data that wasn't analyzed or analyzed closely during the lifetime of the mission. So the discoveries of these rovers are going to keep coming, and coming. Yes, back here.
When you have a mission that's supposed to last 3 or 4 months and it lasts 5 years, where does the extra funding come to keep all those scientists deployed and analyzing everything?
Okay, that's a great question. Where does the funding come from? And every year, the Mars rover team has to go to NASA and apply for more money and say, well, you know, we want money to do another year of operations for the Mars rovers. And it only costs right now, I think the current cost is about $10 million a year to keep both rovers operating. So we've got these 2 spacecraft operating on Mars, and it costs a pittance in the overall federal budget to keep them going. So needless to say, when they go to Congress, or when they go to NASA and Congress to ask for that money, they're not going to have, as long as these things are moving and the science instruments and cameras are working and they're communicating, they're going to get the money. It's an absolute no-brainer. Now let's say Spirit, they can't get it unstuck. I don't know then. I mean, because you can still use it. I mean, take pictures, atmospheric data. It still can do useful science. But if it can't move, my guess is after a certain period of time, I don't know what that would be, then eventually they would call an end to the mission, and maybe